Hi guys, this is a video for chapter 10, lesson 3. So, in this video, we're going to be taking a look at triangles. And so I'm actually going to do the back of the study guide first, and we're just going to break down the types of triangles based off of their angles and by their sides. And so this is something that you've probably looked at before and are maybe a little bit familiar with, but basically for the types of triangles, we have three types separated by their angles. The names of the triangles are classified by the names of their angles. And so, so the first type we have is the acute triangle. And the acute triangle is basically where all the angles of the triangle are between 0 degrees and 90 degrees. So it's all the angles are less than 90 degrees. Okay, so smaller than a right angle. And so if you see like a right angle like this, that's 90 degrees. Okay, it makes two perpendicular lines. So the next type, the opposite of that, would be an obtuse triangle. And that's where one angle is greater than 90 degrees. So one angle, and I'm going to use this symbol to show angle, is greater than 90 degrees. So you can kind of tell here, this angle is definitely bigger than a right angle. So this is an obtuse triangle. And then the third type is the right triangle, which means there is one right angle. Okay, so those are the three types. And you can kind of think an acute triangle is super cute. So it's like the smallest one where all the angles are the smallest. The obtuse is where one of the angles is greater. And then the right triangle, in the name itself, you can tell there's one right angle, 190-degree angle. Okay, now classifying triangles by the sides. So a scalene triangle is where none of the sides are the same measure. No sides are equal. None of them are the same, okay? So we use these little marks. Sometimes we put a little tally, little mark here to show that they are the same or they are different. So if I have one mark here, two marks here, and three marks here, that means all three of them are different. Now for an isosceles triangle, I kind of like looking at the word itself and see that there's two S's and two E's, so that like visually the word kind of helps me think through. This isosceles triangle has two sides that are congruent, okay? So two sides are congruent, and honestly, it doesn't, not at least, just two sides are congruent. And so both of these sides have the little mark here, the same little amount of markings to show that those two sides are the same. And then the equilateral triangle are where all sides are the same. So think about equal means the same, equal. And so all the sides are equal, all the sides, and we call the word we use to show them being the same measurement is congruent. So that's kind of a new word, but all the sides are congruent. And so that's an equilateral triangle. So what we're going to do down here is we're going to measure, classify the triangle by the angles and by the sides. So we're going to name it by either a acute scalene or an acute isosceles, that kind of thing. So we usually name the angle name first and then the sides name. So let's take a look. Number one, it doesn't look like any of the sides are the same measurement. If they were, they would probably put some markings on there so it would tell us. So this is definitely a scalene, and we see a right angle. So this is a right scalene triangle. So we're going to write, it's a right scalene triangle, okay? Number two, ooh, it looks like we have two markings that are the same, so that shows that this is isosceles. And then we've got one big angle here that's greater than 90 degrees, so that's obtuse. So this would be an obtuse isosceles. Okay, And then number 3 here, we have all 3 sides are completely the same measure, and all three all three sides are the same measurement, and all 3 angles are the same. So this is something they didn't mark this very good, but if all the angles are the same, then all the sides will also be the same. And that's something you learn in geometry. But for right now, we'll just call this a acute equilateral. So it's all the sides are the angles are less than 90 degrees. So it's acute equilateral. All the angles are the same and all the sides are the same. Great, and that's basically it. So your homework, you're gonna just classify some triangles based off of the names, and you'll have to remember this because you'll be tested over that. So then another thing we're gonna look at is the measurements of the angles within a triangle. So I'm gonna switch gears here and show you a video because this video gives you a really good visual of how this idea of the angles inside a triangle come about. So we're gonna watch this here real fast.
Okay, so I want to show you a little illustration involving the triangle sum theorem. The triangle sum theorem, which is sometimes called the triangle angle sum theorem because it's really about the angles in a triangle, or the triangle interior angle sum theorem because it's about the interior angles in a triangle. It's the one that says all the angles in a triangle have to add up to 180. And while I know you would probably believe that, I'm going to show it to you in a way that kind of proves it. So let me just start out by talking about a line. I drew a line here, and I just want to go first with the agreement that if I have a line that on one side of the line, like if I think of this as like an angle, where maybe this would be the vertex, one side of a line is 180 degrees. Because remember, all the way around is 360. And 180 plus 180 adds up to 360. So all of the degrees on one side of a line should add up to 180. Another way of thinking about that is a line, which is sometimes called a straight angle. We could think of it as an angle that measures 180. Okay, so assuming you believe that a line measures 180, I have made a triangle. I drew a triangle. Doesn't matter what kind of triangle I drew. I drew one. Mine kind of ended up looking like a right triangle, but it doesn't have to. It could look like any kind of triangle. And I'm going to prove to you that these measurements add up to 180 without ever measuring any of them. Here's how I'm going to do it. First, I'm going to cut out my triangle. And you can do this with any size triangle. Okay, so here's my triangle. It has 3 angles, and again, I'm trying to prove to you that those 3 angles add up to 180. All right, so I'm going to take the angles, and actually, let me number them. I'm going to number them angle 1, angle 2, angle 3. And I'm going to tear up my triangle. I'm not mad at it. I'm just tearing these angles apart. So there's angle 1. And now let me tear apart angles 2 and 3. So I have the 3 angles of my triangle torn apart. So now I'm going to go back to that line. Remember that we said a straight line has to measure 180 degrees. So this time I drew my straight line on graph paper. Here's my straight line. And when I say straight line, really, that's kind of a weird thing to say. It doesn't have any meaning because all lines are straight. If it wasn't a straight line, we would call it a curve. But so, a straight line or a line. And if all this on one side has to add up to 180, then when I put my angles, my 3 angles I tore out of my triangle, up next to the line, with their tips touching, like that's the vertex of the angle, look what's going to happen. They're going to take up all the space on one side of the line, which means they have to all add up to 180. So we have just proven the triangle angle sum theorem, or sometimes it's just called the triangle sum theorem. That the 3 angles of a triangle add up to 180.
Okay, So hopefully that video kind of helped you visualize what we're about to talk about. And you don't need to know the triangle angle sum theorem. That's something you'll learn later. And if you know it now, great, good for you. But really our big focus today is that the sum of the measures of angles of a triangle is 180. So that teacher on YouTube showed us where if we cut off all these angles of the triangle and set them up on a straight line, that we know a straight line, if we measured it out with a protractor, is 180 degrees, and we place these angles onto our line, these angles would all add up to be 180 degrees. So really that means that angle X plus angle Y plus angle Z equals 180. So here's the deal. If we are missing one angle, we can use an algebraic equation to help us find the missing angle. So number one, we're going to say, well, 60 degrees plus 60 degrees plus this third angle, angle X, has to equal 180. So now we can work this out algebraically. And yes, I know you could do 180 minus 60 and find what's left, but I'd like for us to get into the habit of setting up an algebraic equation. So I want you to set it up like this, where you're, even as you're setting it up, you're actually reiterating in your brain that three angles add up to be 180. So 60 plus 60 is 120. And then we're gonna subtract it from 180. So minus 120 on both sides. And 180 minus 120 is 60. So angle X equals 60 degrees. And you can put a little degree sign above so that you know that X equals actually a degree measurement. Okay, so number two, 36 plus 42 plus angle X equals 180. So we're going to add these. We're going to combine our like terms first. So 6 plus 2 is 8. 3 plus 4 is 7. 78 plus X equals 180. Now we're going to subtract on both sides, keeping our equation balanced. And then we have 102 degrees. So X equals 102 degrees. All right, so hopefully you get the idea. So we're going to say 60 plus 50 plus X equals 180, and 110 plus X equals 180. And we're going to practice our solving our algebraic equations. X equals 70 degrees. Okay, and you can double check by adding that back in and adding it to everything to see if it's 180, right? So last one, 25 plus 75 plus X equals 180. And this becomes 100 plus X equals 180. We're going to subtract 100 on both sides. And X equals 80 degrees. Okay, we're not going to worry about number 5. We're not going to worry about the ratios, just because that's just randomly put in there. And so we're not going to worry about that today. But really the big idea we're learning is just some basic stuff about triangles and their characteristics. You'll see this a lot in geometry, so you're kind of getting a head start. And this is good because it helps us practice our algebraic equations as well. And that's all we have.